Now we're going to be talking about a specific type of plurality voting problem called minimum number of remaining votes needed to win. In these problems, some votes in an election will have been counted, and you're being asked to determine how many of the remaining votes, meaning the uncounted votes, how many of the uncounted votes need to go to one candidate in order for them to be guaranteed winning. This means if they get this number of the remaining votes, another candidate can't possibly tie or beat them with any of the other remaining votes that are left. So to get into this, we'll look at an example. So let's say that we've had 50 votes have been cast in an election among 3 candidates, and after the first 30 votes are counted, we have the following tallies. So Alucard has 12, Saifa has 10, and Trevor has 8. First thing they're asking us is what's the minimum number of remaining votes Alucard needs to be assured of winning. Then in part B, they're asking us about another candidate. So important information that we need to know here is that 30 votes have been counted and 50 votes have been cast. So if we were to do 50 minus 30, that tells us 20 votes remain, or 20 votes have not been counted. And this is going to be important for solving this. Let's see, we were asked about the minimum number of remaining votes Alucard needs to be assured of winning. So they have 12 votes, so we'll just make a note of that. Now, the way we're going to solve this is algebraically, and there's a way that we can set this up that'll always work, and we're going to explain what all of these are. So the 12 here is, this is the number of votes the candidate you were asked about has. In this case, we were asked about Alucard, who had 12 votes, so that's why we have a 12 here. The next thing we'll talk about here is this 10. So we were asked about the candidate in first place. So the 10 here, if we go back to this, that's the number of votes the second place candidate has. So what we would put here is number of votes the second place candidate has So the 10 here is the number of votes the second place candidate has if you were asked about the first place candidate, or it's the number of votes the first place candidate has if you were asked about any other candidate. So for part B, you're not necessarily going to have 10 here. If you're not asked about the first place candidate, if you're asked about anybody else, however many votes first place has would go here. Now we'll talk about what this x is. So this x is the number of votes needed for the two choices you're putting against each other here to tie, or the number of remaining votes for the two choices to tie. Now over here, this 50 minus 30, which is equal to 20, this is the number of votes not counted yet, or the number of remaining votes, however you prefer to think about it. So now all we have to do is solve this algebraically for x, and we'll be able to find our solution. So we'll rewrite this out. We have 12 plus x equals 10 plus 20 minus x. So first thing we can do here is these parentheses don't matter. We're just keeping this separate for now. But we can start to add these across. So this is going to be 10 plus 20 minus x equals 12 plus x. So we have 12 plus x is equal to 30 minus x. Now what we can do is we want to isolate the x. We want to put them together in this case, so I'm adding x to both sides. This gives us 12 plus 2x equals 30. We're going to subtract the 12. We want to isolate the x, so we're moving other things away from it. We do 30 minus 12, that's 18. Now we divide both sides by 2 to isolate this x, and we end up getting x is equal to 9 votes to tie. However, we were not asked how many votes they needed to tie. We were asked what's the minimum number of remaining votes they need to win. So if 9 votes will guarantee a tie, 10 votes is how many they need to win. So this is our solution. So now we'll look at part B. So part B was asking what's the minimum number of remaining votes Saifa needs to win now. So if we go up here, we see she has 10 votes. When we set this up, okay, that was a mistype, so this should be 10 instead of 8 here. Anyway, in setting this up, this is the number of votes Saifa has. And she was not in first place, so we need to put her against whoever is in first place. So the 12 votes up here is the number of votes first place candidate has. Now up here, again, 50 minus 30, that stays the same because we still have 20 votes that haven't been counted yet, and the X's are still going to stay in the same place. So now all we need to do is solve this algebraically, and we'll see how many votes she needs to be guaranteed to win. So going through this. Okay, so first we combine our 12 and 20 here. Now what we want to do is, combine these x's and then isolate the x. Let's see, we could, subtract 10 from both sides here. So we end up with x is equal to 22 minus x. Add x to both sides. We get 2x equals 22. Divide both sides by 2. We end up with x is equal to 11 votes to tie. So we need 12 votes to win. Now let's look at another example. So let's say we have 45 votes cast in an election among 3 candidates. We've counted up 25 votes. We have tallies for our 3 candidates, and now they're asking us, what's the minimum number of remaining votes Armin needs to be assured of winning? So what I'd suggest you do here is pause the video, take a couple minutes to try and solve it yourself, and then keep watching, and you'll be able to see if you, solve this correctly or not. Okay, so we'll start to set this up. So the first thing we need to know is the number of votes the candidate that we were asked about has. We were asked about Armin. We're told here that he has 8 votes, so we're going to put down an 8 because that's how many votes he has. So now that's plus x, which is the number needed to tie, is equal to, so now we need to see if Armin is in first place or not. If Armin is in first place, we're going to put the number of second place votes here. If Armin is not in first place, we're going to put whatever the first place number of votes is. And in this case, Armin is not in first place. The first place candidate has 11 votes, so 11 is what we're going to put here. Then we're going to add to this the number of votes not counted yet. So we had 45 votes, 25 votes were counted, and then that minus x. So this is what we're going to end up solving. So here now we have 8 plus x is equal to 11 plus, see, that's 20 minus x. Now we just need to solve this algebraically. So we have 8 plus x is equal to, we have 31 minus x. And we can add x to both sides to undo the subtraction over here. We can subtract 8 from both sides. We end up with 23. Now we divide both sides by 2. And we're going to end up getting x is equal to 11.5 votes to tie. Now, looking at this, 11.5 votes is not a number of votes you can actually have. You need to have a whole number of votes. We can't have something like half a vote, but that's okay because this is just how many they would need to tie. And we were being asked how many votes they need to be assured of winning. So if they need 11.5 votes to tie, 12 votes is going to be the minimum they need to win. Now, this is just something important to remember. We saw this in the last example, but in problems like this, if you end up solving and you get something like, 1.5, 11.5, like we saw, 9.5 or something else for the number of votes needed to tie, you would round up to the nearest whole number to determine the number of votes needed to win.